We want to check in with Richard Allen, who's the director of the Berkeley Seismology Lab. Thank you so much for being with us. I'm interested to know, how did this all unfold for you all at the lab this morning?
Well, actually, believe it or not, I was giving an exam to a very large class of 500 students who were taking the earthquakes class.
No way.
And during the middle of the exam, all of our phones went off. Everybody has the MyShake app downloaded, so they get the early warnings. So everybody's phone went off, and the exam continued. So that's how the earthquake.
Oh, the exam continued.
And keep it going.
So you're that kind of professor.
Well, you know, they're all prepared. They are all ready. They get the alerts. They know what to do. So we continued with the exam.
How long of a notice do you think you got there?
We got, I mean, not much. It was maybe a second or two notice before we felt shaking. The shaking here was very light indeed. I'm in Berkeley, and the shaking here, some people did feel it, some people did not feel it. So very light shaking. Clearly people felt much stronger shaking in other places. I had messages from folks in Santa Cruz, for example, who got the warning and then felt the shaking as well. So it's great. You know, as you know, earthquake early warning is a relatively new technology. The alerts are currently delivered using the MyShake app and also using Android phones as well. And clearly the alert got out across the entire Bay Area. So it's great to see this new technology really working pretty well in this earthquake.
Mm-hmm. Yes, and also thanks in part to Berkeley.
Yeah.
That's right. Yeah, we've been working on earthquake early warning for quite some time. That's right. So the system that puts out the alerts is Shake Alert. So it's a system that is run by the U.S. Geological Survey and also by the California Office of Emergency Services, and it has been an effort underway for over a decade to build an earthquake early warning system. So this is sort of a really nice test, if you like, of the system. Magnitude 5 like this, of course, is not a huge earthquake. We don't expect very much damage, if any damage at all, for an earthquake of this size. So in that sense, it's a good reminder for all of us that we live in earthquake country. We need to be ready for much larger earthquakes than this. And of course, it's a test for the early warning system.
You mentioned that. What kind of things do you think can be gleaned from this experience to maybe make the system better?
Yeah, the early warning system, of course, is sort of very focused on very rapidly detecting the beginnings of the earthquake and getting that warning out, because we know we only have a few seconds to do that. But one of the things that we don't really understand, or rather I think we can better understand, is just who wants the warning like this. So for example, we currently send the warning out to the area where we expect to see shaking intensity 3. Okay, so that's not the lightest sort of gradation of shaking. It's the second lightest gradation of shaking. And our impression is that people like that. People, when there's an earthquake like this, when there's an earthquake that is being discussed on the news, it's a significant earthquake, then people want to get the warning if they are likely to feel shaking. But that's one of the things that I think this earthquake can teach us, is we will study pretty hard the feedback we get from people getting this warning, and are we alerting the right group of people? Do we need to alert a wider area or perhaps even a smaller area when we have an event like this?
You just mentioned something about, did you say a Shake 3? Can you explain a little bit about how you developed that scale, what that means?
Absolutely. Sorry, the shaking intensity 3. So when we talk about earthquakes, we always talk about the magnitude. We're talking about the fact that this is a magnitude 5.1 earthquake. And so in an earthquake, there is just one magnitude. It was a magnitude 5.1. But of course, what matters for me, what matters for you, is what was the shaking intensity? How strong was the shaking at your location? And of course, if you're close to the epicenter, you have stronger shaking. If you're further away from the epicenter, then you have lighter shaking. And so the intensity scale, so you can see actually on that map right now is showing what people reported in terms of the strength of the shaking. You can see the sort of teal colors are the strongest shaking closer to the red star there, which is the epicenter, and the shaking intensity decreases as you get further and further away. So the question for early warning is, how far out do we send the warning? Do we send the warning all the way out where anybody felt shaking? So it would be all of the colored dots on that shaking intensity map that we're looking at right now, or do we just send it to the people who feel the strongest shaking, the people who are closer to the epicenter? Exactly.
And so I think, Mike, when you had this zoomed in more, when you were getting closer to San Jose, there were some people who were in the yellow. It's mostly in the greens and blues, which are 3s, I think, or smaller than that. But I think the yellow was it a 5 or 6? Does that sound about right, Doctor?
Yeah,
on the shaking
I'm
scale.
gonna pull up a map and look at the map right now. And that's the beauty of this, is we can see exactly what the strongest shaking was. It looks to me that the strongest shaking was a shaking intensity 4.5.
Okay, got
So
it.
the shaking intensity right at the epicenter was about a shaking intensity 4.5 in this earthquake.
And that's a pretty good shake.
Yes. So I will say this is not a large earthquake. It's a moderate earthquake. But I'm also very confident that the people close to the epicenter, many people in San Jose, felt like this was a pretty good shake. But that's where we all need to remind ourselves that this was a magnitude 5 earthquake. We also all know that we have to be ready for a magnitude 7 earthquake in the Bay Area. And the reason it's called a magnitude scale is that as you go up this scale, you're going up by an order of magnitude. So when you go from a magnitude 5 to a magnitude 6, the shaking is 10 times stronger. And when you go to a magnitude 7, it's 100 times stronger. So yes, this was a good shake. People in San Jose would have felt like they felt a good shake, but it's about 100 times less than the shaking that we must expect in the earthquake that we all know is coming, a magnitude 7 earthquake in the Bay Area. So again, what we take away from this is a reminder, what we need to think about, what we're going to do in those large magnitude earthquakes that we all know are coming, but we all need to be reminded to be ready for them.
Can I ask a quick question? So you said the 4.6 was the shake intensity at the closest station. We know it was a 5.1. Is that due to depth in the vertical? Is it due to distance in the horizontal? Why is there that little bit of discrepancy?
Yeah, no. So the 4.5 is the intensity, is the shaking intensity, as opposed to the earthquake magnitude. Sorry if I didn't make that clear. So that the strongest shaking closest to the epicenter was a shaking intensity of about 4.5. Whereas the earthquake magnitude, so that's a different scale, the earthquake magnitude, the magnitude 5.1. So that's the reason. But also, as you said, that's another important point, right? The earthquake was at about 7 kilometers depth. And so, of course, the strongest shaking is at the epicenter. But the actual amplitude of ground shaking does, of course, decrease as you move up to the epicenter from the focus of the earthquake at depth. But of course, there's nobody there to feel that shaking.
All right, thank you. Makes sense to me now. I appreciate that. Because it's all about the energy it's releasing and how much shaking you're getting at your particular area.
That's exactly right. And the other piece, when we think about shaking, when we talk about the strength of shaking, is you also have to think about what type of ground that you're on, right? So around the margins of the bay, where there are soft sediments, man-made land, that tends to amplify the effects of ground shaking. Whereas if you're on a hard rock site, up in the hills on the hard rock sites, then that decreases the effect of shaking. And so you feel lighter shaking there as well. So those are all the factors that come into this issue of how strong the shaking you feel at your location is.
Yeah, I guess that was kind of the point I was trying to make earlier too. Because this happened up in the hills near Mount Hamilton, that helped disperse some of the energy before it reached down to the lower elevations where most of us live. Is that a fair assessment?
Yeah, so that's right. So as you get further and further away from the epicenter, the amplitude has decreased. That's right. So the fact that it's in the mountains and not right beneath the bay means that the energy is decreased by the time you get to the bay. But then when you get to the actual soft sediments in the bay, that amplifies it a little bit again. That's right. So there are these two effects. It decreases with distance from the epicenter, but then increases with those soft sediments and the man-made land.
So we were lucky that it was where it was and the depth of it was, because if it was shifted 30 miles to the west, it'd be right in the heart of the valley, and then you could expect a lot more shaking, right? And a lot more of that softer sediment to be shaking.
That's exactly right. No, that's exactly right. Unfortunately, you can't really win in the Bay Area. The mountains, where the mountains are, is where the faults are, and so you're relatively close to the faults if you're in the higher land. And then as you go to the low-lying land, that's where there are softer sediments, and so again that amplifies the shaking. Bottom line is that, we are going to, all of us, wherever we are in the Bay Area, are going to feel strong shaking in earthquakes, and we need to be ready for it.
All right, well, thank you for your time. We definitely appreciate you checking in with us and giving us more of that information so we can understand exactly what to expect next time we have something like this, and especially if it's in a more dangerous place than where this one was. So thank you very much. Appreciate your time.